Hello, I'm Emily from the Economics Tutoring Center, and today we're going to go over the graphs for a monopoly. So working on cost curves in a monopoly situation as opposed to a perfectly competitive situation. Now before I begin, I'd like to remind you that notation is just changed by professor. They each use different techniques, so be sure to check with them before you employ any of these exact methods. Alright, so as I said, this is a graph of a monopoly, and we're able to tell that because of this marginal revenue curve. Now normally when we're in a perfectly competitive market, our marginal revenue is equal to our demand, and we have a horizontal line for marginal revenue. However, because this is a monopoly, we have a sloped curve for marginal revenue, and there's this gap between marginal revenue and demand. So that's how we can tell it's a monopoly. And then going over these curves, this is marginal cost, average total cost, which remember is comprised of both our variable costs and our fixed costs. That's going to be important later. Demand, like I said, marginal revenue, and then I've just gone through and labeled a few prices. So starting off, where do we operate? At what quantity are we going to operate at? Well, we know that where marginal revenue equals marginal cost, we have our optimum operational point. And this is true for any graph that we're working with. So we have our marginal cost line right here, our marginal revenue here, which brings us to this intersection point, right? And that we're going to go ahead and just label as Q1 because this is our quantity. So our optimum quantity that we're going to operate at, that this monopoly is going to operate at, is Q1. So I'm going to go ahead and write this right here. Now, if we were in a perfectly competitive situation, we would also take this corresponding price. But as we can see here, at this quantity, people are willing and able to pay a higher price. So we see right here that for a quantity, this given quantity, we can call it anything we want, let's call it 3. So at a quantity of 3, our marginal revenue is at price 1. So I'm going to go mark that over as well. But our demand is higher than that. So if people are willing and able to pay a higher price, as a firm that wants to maximize our profits, we're going to take that price. So although our quantity is where these intersect, our price, labeled P, is going to be where that quantity meets our demand curve. So we pulled that quantity up all the way until we met demand. And so that's going to give us P2. All right, so at this point, there's a few things that we can do. We can determine our total costs, we can determine our total revenues, and from that, we can determine our total profits. So, at this point, Q1, what are our total revenues? Well, we know that revenue is equal to price times quantity. And we said that price was P2 and quantity was Q1. So, if we want to draw this in a more graph way, we can go ahead and call it this entire area. So our our total revenue is going to be from 0 to P2 to Q1. So this box right here, which we can also notice as price, the height of our box, times quantity, the base of our box. Remember a rectangle? Just base times height. So the area of this box is going to be our total revenue. Now, if we want to look at total cost, we have to compare where our average total cost is to our quantity. So taking the same quantity again and finding where that intersects our average total cost, we actually have to go up a little bit higher. So corresponding to price 3, our average cost at Q1 is price 3. So if we want to move from an average total cost to our total cost, we're going to multiply this price, so a height times this quantity, the base, and we're going to end up with an even larger box. So that puts us at 0, P3 to Q2, to Q1 for total cost. Now you'll recognize here that our total cost box, because that went all the way up to P3, is going to be greater than our total revenue. So if we have costs that are exceeding revenue, what we know is that we're making negative economic profit. And all that's saying is that we're paying more to make a good than we are receiving when we sell it. So this box right here is going to be representative of the difference between our total cost and our total revenue. So this box that I've shaded in from P3 to P2 to Q1 is representative of our profit. It's also negative economic profit. Now, this is where it gets a little bit more tricky conceptually. So we know that no matter where a firm is operating, so whether they're a monopoly or whether they're perfectly competitive, they're not going to continue to operate in the short run if they can't cover their variable costs. So we need to make sure that our revenue covers our variable costs. And so we know that our revenue is at P2, right? Because when we were calculating where our quantity met our demand curve, we're going to be charging a price at P2. So keeping in mind that we're at P2, does that cover our variable costs? Well, remember we said that average total cost was the sum of our average fixed and our average variable. So normally when we're given this graph, we're also given a curve that represents average variable cost. However, the way I've set this up and the way it's depicted, we don't have that curve. So we can't definitively tell where our shutdown price would be if we don't know where our variable cost is. So we can say that we would operate at Q1 and P2 because that's where our revenue was if it covers our variable cost, but we don't truly know that. So I'm going to go ahead and draw in two different examples, one that would cause us to shut down and one that would cause us to operate. So what I'm doing right now is I'm going to be adding back in an average variable cost curve. So remembering that average variable cost is part of average total cost, it's always going to be below our average total cost curve. So I'm going to go ahead and put it right here for now. So, average variable cost. Now, to determine whether or not we shut down, does our marginal revenue cover our variable cost? Or does our total revenue cover our total variable cost? Our revenue, we were paying P2, or people are paying us P2 for the good. We're charging P2. And our variable costs, what are they at that quantity? Remember, we're still looking at Q1. This is the magic quantity. Where does Q1 intersect this variable cost curve? Well, looking back up here, I'm going to shift back to black because I've been using that for correlating prices. So where does Q1 meet ABC? Dragging that up. We're going to call that PX. Now, if PX is representative of our variable cost and P2 is representative of our revenue or our price, does our revenue cover our variable cost here? And the answer is yes, because our variable cost box would end up being whatever our variable cost is, PX, times our quantity. So we get this box. And we've already drawn in our total revenue, which was here. And we have this definitive answer that yes, our total revenue does cover our variable costs, and so we can operate, but we are still going to be taking this negative economic profit. Now I'm going to draw in another situation. So what happens if we have a different kind of variable cost curve? Something that was placed differently on the graph. So what if our variable costs were very, very close to our total? So I drew something like this. Recognize that these are much, much closer together than they were when I drew the variable cost curve previously. So I'm going to go ahead and highlight this demand curve again because it's getting a little bit hard to see. But we know here, once again, that our total revenue encompasses this box at P2, and our variable cost at this magic quantity again moves us up to here, which gives us a quantity of, I'm going to say PX2. So on this second average variable cost curve I've drawn in, our price is above, our price of variable cost is above our revenue. So if our revenue is here, the price we're charging, because remember that's where I met the demand curve, is below where our variable cost intersects the quantity, we shut down. So in this situation, we're not going to make anything. We're actually going to operate at zero because we've realized that our variable costs are not covered by our revenue, and therefore we're not going to make anything. And that's because if we shut down, we only have to pay our fixed costs. All right, so that's all for today that we have for the cost curve in a monopolistic market. If you have any more questions or need any more assistance, feel free to come back to the Economic Tutoring Center in the BA building. Goodbye.